This is question 5 and it's a question about probability and probability trees. So we're told that Amanda has 2 fair 3-sided spinners, so they can either land on 1, 2 or 3 with an equal chance of landing on either of any of the numbers. And it says that Amanda spins each spinner once, and we've got to complete the probability tree diagram. So here we've got 2 possible outcomes we're looking at. So it's either going to land on a 2 or not land on a 2. So because it's equally likely to land on any of the numbers, it's one way of landing on a 2 out of 3 possible outcomes. So the probability of landing on a 2 for spinner A is 1/3. And then with the other branch says the probability of not landing on a 2. And so because these must add up to 1 anyway, so this probability here and whatever probability it is on the other branch has got to add up to 1, this must be 2/3, because we can see that 1/3 plus 2/3 adds up to 1. Another way of looking at it as well is that there were 2 ways of not landing on a 2, so that's why the top of the fraction there is a 2 out of 3 possible outcomes. Now if we look at spinner B, which is anything from there onwards, so if I drew a dotted line down there, this would be spinner B. And spinner B is exactly the same as spinner A. So the probability of landing on a 2 is going to be, for spinner B, it's going to be 1/3. And the probability of not landing on a 2, again, is going to be 2/3. And this is just spinner B, but given that the first one had not landed on a 2, spinner A had not landed on a 2. So this is just going to be exactly the same. So this is 1/3 and 2/3 again. And now what we've got to do is use our probability tree to work out the probability that spinner A lands on a 2 and spinner B does not land on a 2. So we've got to look at what route that would be. So that would mean going this way to land on a 2. So that's 1/3. And then going this way to not land on a 2. And that's 2/3. And what we can do, we can actually times them 2 together. Because when we have something called independent probabilities, which is what this is, because we've got 2 things that are happening which don't affect each other. So we can see whatever happens on spinner A doesn't affect what happens on spinner B. So they are what's called independent events. So for that, we can actually times them together. And if we do that, we'll just treat it like a normal fraction multiplication. So we times the top line there and we get 2, 1 times 2 being 2. And if we times the bottom line, 3 times 3 is 9. So we've got 2/9. And that's the probability of spinner A landing on a 2, but spinner B not landing on a 2. And that's it. So I hope that's been helpful to you. And if it has, please consider subscribing to our channel and also giving the video a thumbs up. Thanks for watching.